Today, we're going to peel back the layers on how AI actually thinks. And what's being discovered isn't just a souped-up version of human logic. No, it's something else, something complex and, frankly, kinda alien. A whole new way to perceive a world that's made up of nothing but text. So let's just dive right in. Okay, so it all kicks off with this simple mystery, a real head-scratcher. An AI, like Claude, can do things that seem completely visual, right? Like knowing exactly when to start a new line of text so it fits neatly on a page. But it has no eyes. It can't see a page. So how in the world does it know it's about to run out of space? And this is where you start to see just how differently we perceive the world. You and I, we look at text and we see a block of words. There's a top, a bottom, a left, a right. But for the AI, it's just a one-dimensional conga line of numbers or tokens. That's it. It has no built-in idea of space, so it has to invent that sense all on its own. So how does it pull that off? Well, the first clue that researchers uncovered was that the model basically grows its own specialized brain cells, what they call features. And each one of these features gets really good at one specific counting job. When you look at these features, it seems like the model is running a nice, logical, three-step program. First, some features keep track of how many characters are in the current line. Then, other features use that info to figure out the distance to the edge of the page. And finally, it takes that number and checks if the very next word it wants to write is going to fit. Seems pretty straightforward, right? What's really cool is that there's a parallel in biology for this. These counting features behave almost exactly like place cells in the brain of a mouse. Those are neurons that only fire when the mouse is in one specific spot in a maze. It's like the AI has built its own mental map for navigating this world of text. But here's the plot twist. While that whole explanation is true, it's not the whole story. If you try to explain everything using these thousands of individual features, you get a super messy, complicated picture. The researchers call this paying a complexity tax. The real story, the one hiding underneath, is actually far more elegant and a whole lot weirder. And this is where we get to the big aha moment. Researchers started to realize that these features weren't just a random collection of counters. No, they were all perfectly arranged as points on some kind of hidden geometric shape. That shape has a name. It's called a feature manifold. Now, just think of it as a really sophisticated, curved object that exists in a high-dimensional space. A space that has way more than the 3 dimensions we're used to. The AI uses the very geometry of this shape to pack in information with incredible efficiency. So this is the crucial part. Instead of counting on a simple number line like we would 1, 2, 3, 4, the AI maps those numbers onto this complex, twisting, rippled curve. This shape allows it to store a massive amount of positional information inside a relatively simple 6-dimensional space. It's just a much smarter, more robust way to do it. But it gets better. These shapes aren't just static storage containers. The AI is actually doing its calculations by physically manipulating these shapes. The algorithm isn't a list of instructions, it's a dance of geometric transformations. For example, when it needs to check if it's getting close to the end of a line, it takes the shape that represents the current character count and it geometrically twists it, trying to get it to line up with the shape that represents the total width of the line. And when those two shapes align just so, bam, it creates this huge spike in the model's internal attention. That spike is the signal. That's the AI's internal system screaming, hey, pay attention, we're getting close to the edge. So what about the final decision to break the line or not? It's almost poetically simple. Imagine dropping a ball onto a tilted surface. The model's calculation puts a point in space. On one side of a dividing line, the word fits. If it lands there, it writes the word. If it lands on the other side, it predicts a new line. That's it. Now, this all sounds pretty wild, I know. How can we possibly be sure this is what's really going on? Well, think about it. If the model is truly seeing with geometry, then we should be able to create a kind of optical illusion for it, something that messes with its perception of space. And that is exactly what the researchers did. They discovered that certain characters, like the double @ symbol you see all the time in code, are powerful signals. So they took a normal sentence and just dropped @ in the middle of it. The idea was to distract the part of the AI's brain that was busy measuring the line. The results were just wow. Staggering. For the original sentence, the model was 79% confident it needed to start a new line. But after they inserted the at illusion, that confidence just plummeted off a cliff, all the way down to 8%. It totally broke the model's sense of space, proving that this geometric mechanism isn't just a theory, it's real, and it's what's driving the decision. Okay, so let's pull back for a second. This whole deep dive is about so much more than just where to put a line break. What we're really getting here is a rare window into the fundamental way that an AI's mind actually works. So what are the big takeaways? First, AIs can literally invent new senses, like a sense of space using nothing but text. Second, they seem to have a built-in preference for beautiful, elegant geometric answers instead of just counting on their fingers. And finally, and this is the big one, these hidden shapes might actually be the basic language of AI thought, and we are just now learning how to read it. The researchers who discovered this said it best. If you only look at the individual features, you shatter the model into a million confusing pieces. But if you can find the underlying geometry, you get rid of that complexity tax, and you reveal the simple, powerful idea that was hiding there all along.
And that really leaves us with a mind-bending final question, doesn't it? We've just learned that AI is using these hidden, high-dimensional shapes to reason about the world. It just makes you wonder, what other secret geometries, representing who knows what complex ideas, are still out there just waiting for us to find them?